You're standing on a sidewalk. An ambulance is coming. You hear it before you see it. The siren is high, sharp, urgent. Then it passes you, and in less than a second, the pitch drops. Same siren, same speaker, same volume, but your brain just heard two different sounds. Here's the strange part. Nothing about the siren changed. Nothing about your ears changed. The only thing that changed was the space between you and it. This is the Doppler effect. And once you understand it, you'll never hear a passing car, a bird call, or even starlight the same way again. Start with the basics. Sound is a wave. It moves through air the way ripples move through water. Every time the siren blares, it pushes out a wave of compressed air, then another, then another. Each wave travels outward in every direction, evenly spaced, like ripples from a stone dropped in a still pond. When the ambulance is sitting still, those ripples spread out symmetrically. You hear a steady pitch. But the ambulance isn't sitting still. It's moving toward you, and that changes everything.
Picture the ambulance emitting a new sound wave every fraction of a second. As it moves forward, it's chasing its own waves. Each new wave gets emitted from a position slightly closer to you than the last one. The waves in front of the ambulance get squeezed together, compressed, bunched up. Sound pitch is just how frequently those waves hit your eardrum. Squeeze the waves closer together, and more of them hit your ear every second. Your brain interprets that as a higher pitch. That's why the siren sounds sharp and urgent as it approaches. The ambulance is literally packing more sound waves into the space between it and you. Now, the ambulance passes. It's moving away. The opposite happens. Each new wave is emitted from a position slightly further from you than the last. The waves stretch out, spread apart. Fewer of them hit your ear each second. Lower frequency, lower pitch. That sudden drop you hear isn't your imagination. It's physics, happening in real time, right past your ear. A physicist named Christian Doppler first described this in 1842. He wasn't thinking about ambulances. He was thinking about stars. Doppler proposed that the color of light from a star could shift depending on whether that star was moving toward Earth or away from it, the same way sound shifts in pitch. At the time, almost nobody believed him.
3 years later, a Dutch scientist named Christophorus Boys-Ballet decided to test it. He didn't have access to a moving star, so he did something almost absurd. He hired a group of trumpet players. He put some on a moving train and some standing still on the platform, and had musicians with perfect pitch listen and record what they heard as the train approached and pulled away. The pitch shifted exactly as Doppler predicted. The trumpets weren't playing different notes. The listener's position relative to the sound was changing everything. Here's where it gets stranger. This effect doesn't just apply to sound. It applies to any wave, including light. When a star moves away from Earth, its light waves stretch out, the same way the ambulance's sound waves stretched out as it drove away from you. Stretched light shifts toward the red end of the spectrum. Astronomers call this redshift. When a star moves toward Earth, its light compresses toward the blue end, blueshift. In the 1920s, an astronomer named Edwin Hubble used this exact principle to study distant galaxies. He noticed that almost every galaxy he observed showed redshifted light, not just a few. Almost all of them, which meant almost every galaxy in the universe was moving away from us.
That single observation, built on the same physics as a passing ambulance, became one of the strongest pieces of evidence that the universe is expanding. Think about that for a second. The same reason a siren drops in pitch as it drives past you is the same reason we know the universe is getting bigger. A trumpet on a train, a galaxy billions of light years away. Same wave, same rule. Your ears have been doing astrophysics your entire life. You just never noticed. Doctors use this principle too. Ultrasound machines send sound waves into your body and measure how those waves shift when they bounce off moving blood cells. Faster blood flow shifts the frequency more. That's how a Doppler ultrasound can show a heartbeat or check for blocked arteries without ever cutting the skin. Police radar guns work the same way. Bounce a wave off a moving car. Measure the shift, calculate the speed. None of this requires anything exotic. Just a wave, a moving source, and something to listen.
So, Next time an ambulance passes you on the street, listen closely to that drop in pitch. You're not just hearing a siren change. You're hearing the same physics that told us the universe is expanding. The same physics doctors use to look inside a beating heart. The same physics that once made a Dutch scientist put trumpet players on a moving train just to prove a stranger's idea right. The siren fades. The ambulance disappears down the street. But the wave was never lying to you. You were just standing in the wrong place to hear the truth. Thank you for watching all the way to the end. If this made you hear the world a little differently, like this video, share it with someone who loves a good mystery, and subscribe for more stories hiding in plain sight.